Now, coming to for each loop. So what exactly for each loop? If you remember, we spoke that we actually discussed earlier that Java has three types of for loops. One is simple for loop, another is enhanced for loop, another is for each loop. So each has a different purpose, right? Now here we are going to talk about for each. The biggest advantage you get with this kind of loop is you don't need to worry about iteration. It automatically takes care of iteration. When I say iteration, repeating the loop one by one and printing the elements, and you don't need to worry about what is the initial value. You don't need to worry about how to increment. All that is taken care. I would say this is the more comfortable loop where you don't need to worry much. So let me show you how this works. So if you see, by looking at the syntax itself, you can understand. In while loop, always remember, in while loop or do while, you should always think about what is my initial value. Where do I start with? And then you have to think about when should I stop my while loop, which is your 10 meeting condition. Again, in while loop, one more thing aspect you have to look at is whether I have to increment or decrement. Three things you must always keep in mind. In the case of for loop, this all headache is not there, because for loop automatically understand the initial value from the data you have given. That means initial value, you don't need to take it. Another thing is it automatically knows what is the length of your collection or array. It actually takes both array or collection as input, and it automatically understand that should I have to go, how many elements I have to traverse. It knows that because it has a logic where it automatically figures out that we don't need to worry about terminating condition also. Now coming to increment and decrement, also it takes care because it remembers the state where it passed. So all this makes people prefer for loop, because you don't need to worry about all these three things which you always have to keep in mind when you use while loop or do while loop. But these are all meant for one reason only. These are all meant for looping some set of statements. You can use it for traversing arrays, you can use it for traversing file lines in a file, you can use it for traversing list of elements in a array or any other collection, all that you can do. And one more good thing about this for loop is, since you don't need to worry about iteration, condition termination, or increment or decrement, there's a less chance of you making errors because other things are not need to be worried about. Another thing is it makes your code more readable to understand because it's just simply for variable, array, or collection. So it takes input as array or collection, and it automatically walks through it all of it without any step value or anything like that. And one more thing to put it out here is, when we say simple or more readable, it simply means that it makes your code more elegant. You will not write a lot of unnecessary statements which is not related to really repeating the loop. If you look at while and do while, you have to write certain things in order for the loop to work. Like one thing is your terminating condition, another thing is that step value, increment or decrement, which is not really, if you look at it, they are not really closely related to the what is your purpose in repeating that. They are related to that loop, not to the purpose of it. But here you will not have that. That means the code looks more simpler and more better manageable and readable. So let's look at this with an example. If you see here, the same 13, 14, 15, 46, we need to print it. And you can either print it or sum it. Here in this case, we are summing it. So how does it happen? So here, when we say int x colon a, if you see there's no initial value, just like while loop, it automatically figures out I have to start with 13. So each time what happens is it picks first element 13 from this array a, which is nothing but this, and it puts in x. That means now x is 30. Now, once it do this part, now what happens is now sum equal to sum plus x. Now it sums with this 13 plus 0 because the initial value of sum is 0. Now 13 is, s is your 13. Okay, so s is your 13. Now, once you do that s equal to 13, now similarly you get 14 next time. So it automatically moves to the next element. Now 14 plus sum. What is sum value? 13. 13 plus 14, 27. So it automatically adds and makes it the sum. Similarly, once 27 is done, the other value it picks it, which is 15. And 15 plus 27, it is 42. So that is get added. Now again 42 plus 46, it is 88. Like that, it keep on getting one value and adds it. Here if you see, we are just doing the main purpose of the loop. We are not doing anything like, just adding the incrementing or decrementing or terminating addition, nothing like that, which is not related to this particular use case. In this use case, we just have to sum the value and we have just done it. So this is what we are saying. It makes the code more readable because you're not writing any unnecessary things, right? We are saying here makes more code made readable because you're not writing anything related to the loop. You're just writing to the purpose of it. And there's less chance of errors because you're not worried about step value, terminating condition. Those headaches are not there. So this is more elegant and comfortable loop, I would say. Okay. So that's about this for each loop. And and one more thing to remember in for each loop is these guys are very helpful if you know how many times the loop has to run. That means if you say, I don't know how many times the loop will run, it can run endlessly. This guy is not the answer. Then you have to go for do while or while loop. There's no other alternative. Any infinite loop, these guys are not going to work. You have another for loop, by the way, the simple for loop you can use, but this for each loop you can use only for finite use cases. That means you know how many times to repeat, then only you should use it. Otherwise, these are not helpful. But if you see, most of our use cases are finite, I mean percentage wise, so that way this is more useful.